All right, so we're continuing on with the test review for Unit 3. We just finished up through number 6. Now we're going to do numbers 7, 8, 9, and 10. These problems can all be found, their addition and subtraction of rationals, and that's found in 3.3. So we did a ton of these problems and did a pretty thorough explanation of all of them in the 3.3 video. So if you need some additional examples worked out for you and an explanation, go over to 3.3, and that'll kind of teach you how to do all those things. Okay, so for these problems, when we're adding and subtracting rationals, just like with fractions, we need to find a common denominator. It looks like on the first one, number 7, they do have the same denominator, so that just means we add straight across the top. So this becomes the following. The denominator stays the same, 16xy squared, because since they're the same, it stays just as 1 in the bottom. Then the top part becomes x plus 5y, and then plus 5x plus a negative 4y, so minus 4y. All right, now we combine like terms. X plus 5x is 6x. 5y minus 4y is 1y, so plus 1y, all over 16xy squared. And now, if you want to simplify this any further, you need to divide something out of all of the terms here. So like 6x, I could cancel out an x here, but I'd also have to cancel it out here. Same thing with the y's. I could cancel them out here, but I'd also have to cancel one out here. But since I don't have x's or y's, I can't really do that. In fact, even the 16 and the 6 can't be reduced any further because there's no number other than 1 in front of the y. So this is our simplified expression. That's as simplified as it gets. All right, so that's the easy one when you have the common denominator. If you don't have the common denominator, an easy trick that you can use is just to multiply by the other one's denominator. Now, for these ones, you need to multiply in the top and the bottom by that denominator, okay? We'll see that that's different when we get to the solving the expressions, but these ones, it's pretty easy, still. So just take the denominator of one and multiply it in the top and the bottom of the other. So 4n squared in the top, 4n squared in the bottom. Okay, so that gets us, let's see, 4n squared times 4m is 16n squared m. And then the bottom, that's 4 times 3, which is 12, and then n squared m to the third. All right, now let's see what we get over here by taking this one's denominator and multiply it in the top and the bottom. So that's 3m squared and 3m squared. So we get minus 2 times 3m squared is 6m squared. And then 4 times 3 is 12. And then n squared, and then m to the second power. Wait. Sorry, that's to the third, huh? My bad. I put m squared instead of m to the third. So that should be a 6m to the third. And then that's 12n squared m to the third. There we go. So now we have the same denominator. So we can do just like what we did in number 7, and that's just add across the top. So we get 16n squared times m minus, then this number, 6m to the third power, all over 12n squared m to the third. Now let's look for common things that we can take out of all three of these terms. Let's start with the numbers. So 16, 12, and 6 are all divisible by 2 at the biggest. So if we divide all these by 2, we get 8. And then that's a 3. And then in the bottom, that's a 6. And you notice that you can't divide any more numbers out of this together, so you just got to leave it like that. Let's see how many n's we can take out of the top and the bottom. So this has an n squared, and no n's. So that means that we can't take n out of all three of them, so we just got to leave them as is. So we have an n squared in the top and an n squared in the bottom, and no n on this. All of them have m's on them, though, so let's see how many m's we can take out. So this has 1m, this has 3, this has 3, so we can take at most 1 out of this. So this m goes away, and then these m's go down to m squares. So this is going to be 3m squared, and then this is going to be 6n squared m squared. And since we can't simplify it any further, this is our simplified expression, so we're all done with this one. The next ones are actually pretty easy if you can just, factor. They get real easy, especially this one because this one's prime, so you can just leave it when you get to it. But this one is extremely easy if you just, factor the bottom. So the bottom part, 3m squared plus 18m, 3m factors out of this. So I get m plus 6. And then, since I have a 3m in the top and the 3m in the bottom, they can just cancel out. So what does that leave me with? Well, over here I have 6m plus 2 over m plus 6 minus, and then the 3m cancels out, so you just have a 1, and then the 3m cancels out here, so you just have an m plus 6. So now I have the same denominator, so I just need to add across the top. So we have 6m plus 2 and then minus 1 all over m plus 6. So 6m plus 2 minus 1 is 6m, and then 2 minus 1 is 1 over m plus 6. And there's nothing you can factor out of all 4 of these terms, so you can just leave it as is. This is your simplified expression. Easy enough. All right, now for this one, we're going to implement the rule that we went over in the previous problem, number 8. And that's to take one's denominator multiplied in the top and the bottom of the other one. So I'm going to start off with k minus 5. I'm going to multiply that in the top and also in the bottom. And then I'm going to take k minus 2 and multiply that in the top and the bottom here. All right, let's see what we get. So 2k, I'm going to distribute that in here. I get 2k times k, which is 2k squared. 2k times negative 2, which is negative 4k. Minus, and then I have to change the signs on all this stuff when I get to it. So let's see what we get. Distributing the 5 in there, 5k. So if I'm minusing it, it turns into negative 5k. 5 times negative 5 is a negative 25. Negative 25, and then applying this negative gets me a plus 25. And that's all over this expression that we have. Never FOIL this stuff in the bottom. Just leave it factored, in factored form, because you're going to end up factoring at the very end anyways. So just leave it alone. All right, combining like terms, we get 2k squared. Negative 4 and negative 5 makes a negative 9, so negative 9k plus 25. And that's all over k minus 2 times k minus 5. And then you can try to factor the top, but it won't factor, so because it's prime, so you can just leave it alone. And this is your simplified expression. What I'd look to do is factor this, and then if I get like a k minus 2 or k minus 5, I'd cancel that out, but we never had any examples like that. All right, so that's 3.3. Remember that you actually have more examples than just the examples on the videos for 3.1, 3.2, and 3.3 because we also did that quiz review that has all those things in it. Okay, so that's it for these problems, and then I'm going to move on to the solving the rational expressions and then graphing. Oh, and word problems. All right, so check out those videos.